let's take a look at this 3D figure. This is a rectangular prism, and we are going to find the surface area, and the surface area is exactly what it sounds like. It's the total area of all of the surfaces of a 3D figure. So let's go ahead and take a look at what we've got here. At the top here, we have a width of 3 and a length of 1, 2, 3, 4, 5, 6. So we have a 3 by 6 rectangle. Think about a box of tissues. If this were the top of a box of tissues, the bottom would be the exact same size, right? So we're going to go ahead and design that. I'm going to start with the bottom. Let's see, we'll come down here. We have a 3 by 6. And I want to go ahead and make this transparent so we can see the grid, because I think that's going to help us. So we're going to label this. All right, so the bottom down here, now we can see the front edge of the bottom and we can see the right edge of the bottom. So here would be the front edge of the bottom and here would be the right edge of the bottom. So considering that, what is attached to the front edge of the bottom? Well, the front face, right? So let's take a look at that. We have a width of 1, 2, 3. We have a length of 1, 2, 3, 4, 5, 6. So we have another 3 by 6 rectangular face. I'm going to go ahead and copy this because it's the exact same size as the bottom. I want to change that to the front. So we're going to change our label there. Now, we said that this was a bottom edge and that this is also a bottom edge. This bottom edge is on the right side of the bottom, which would be right here. And what else is attached to that? Well, this bottom edge is shared by this face that's on the right side of the 3D figure. And this is a 3 by 3 square. So I'm going to go ahead and grab a new shape and I'm going to design a 3 by 3 square here. And that's going to be like that transparent again. Let's go ahead and label it. This is the right side of our 3D figure. Now, what do we know about the left side of the 3D figure? We can't see it, but if we think about that tissue box again, if the right side of a tissue box is 3 by 3, the left side is also going to be 3 by 3. I'm going to go ahead and copy that and paste that here on the other side, and then we'll just adjust our labels. All right, so we have the bottom, the front, the left side, and the right side. Now, what else do we have? Well, along the bottom here, there's something that we can't see, but let's just follow this edge, the front edge to the right edge. If I could see around the back, there would be another edge going through right about here, and connected to that would be the back. And the back is the same as what? Well, the front. If we think about that tissue box again, the front side and the back side will be the exact same size. So I'm going to go ahead and create that here. And we'll change that label to the back. All right, so there's only one more face left. Let's get this adjusted a tad. And that's the top. Okay, and the top is congruent to what? The bottom, right? These two opposite sides, the top and the bottom, will be congruent. That is a 3 by 6. So I'm going to come copy the bottom here. And then I'll place it right here. It's just going to fit. All right. And now we have our 6 faces. 1, 2, 3, 4, 5, 6. Now, how can we find the surface area? Let's think here. I'm going to go ahead and grab my little scribble tool and let's label some dimensions. So 1, 2, 3, the top has a width of 3 and a length of 6. The back has a width of 3 and a length of 6. The bottom has a width of 3 and a length of 6. The front has a width of 3 and a length of 6. The left side has a length of 3 and a width of 3. And the right side is also 3 by 3. So we have everything we need now to find the area of each face. So 3 times 6, or 3 groups of 6, 6, 12, 18. So 3 times 6 is 18. And we're talking about square units. So we have 18 square units. Now, what else is 18 square units? If the top is 18 square units, what else is going to be 18 square units? I'm going to go ahead and use a text box for this section. All right, so 18 units squared. We'll fill that in so it stands out a little bit here. All right, and then the top is 18 units squared, and what else is 18 units squared? 3 by 6, 3 groups of 6. The back is also 18 units squared. The bottom is 3 groups of 6, or 18 units squared. The top shows 3 groups of 6, so 18 units squared. So 4 faces of our rectangular prism have an area of 18 units squared, which means for this part, we could multiply 4 times 18, because 4 groups of 18 would give us the area of those rectangles. Now I know 4 times 10 is 40. And I know 4 times 8 is 32, and 40 plus 32 is 72. So the rectangles have an area of 72 square units. Now we have 2 other faces. Now these are also rectangles, but more specifically, they're squares, okay? Because these faces have congruent side lengths, so 3 by 3. So how are we going to find the area of the square? Well, we have 3 groups of 3, or we could count those up either way, or 3 times 3. So I'm going to go ahead and come over here, and we'll do 3 times 3. 3 times 3 is 9, and we're talking area here. So 9 square units. And then how many faces do we have like that? Well, we have 2. So again, I'm going to use my text box here. I've got 9 units squared, and we'll fill that in so it stands out here. And then the side opposite that is also 9 units squared. All right, so let's go ahead and take a look at what we have. Let's notate that. So we have 2 faces that are 9 units squared, and 2 groups of 9 is equal to 18. So the area of the square faces is 18 square units. All right, so we're getting there, but what's next? We have the area of our rectangular faces, 72. The area of the square face is 18. We need to find the total area. So what do we need to do now? If you said add them together, you're exactly right. So we're going to add 72 and 18. 72 units squared plus 18 units squared equals, well, I know that 2 plus 8 is 10, and 70 plus 10 is 80. So 80 plus 10 is 90. So we have a total surface area of 90 units squared. So just to recap, When we're finding the surface area of rectangular prisms, we need to find the area of each face, and then we're going to add them together to get this total surface area of the 3D figure.